We are creating heap using binary search tree. Here we are inserting data and then deleting an element from the data and checking what's the new root node that we have. So let's run the program. So after inserting the data, deleting an element, 4 will be removed because it's a min heap, and then the new root node that we have is 5. For the priority queue, using NQ operation, we are inserting data into the priority queue. Using DQ operation, we are removing the data from the priority queue. So 4, 7, 5, 11, this is data and also the priority of the data. So after DQ operation, 4, 5, 6 is removed. And to perform the command line interface, I have created a batch file here. So if I press 0 to NQ, let's enter the element 1. And then to DQ, let's press 1. So the number 1 is removed from the priority queue. And then to exit, let's press 2. Let's go back to the code. So in this code, we have a class node, which has different properties. And the class heap, we have this constructor where if we want min heap, we can pass value true here. The size of the heap is the global variable which keeps the count of number of nodes in the heap. To insert the data, first we are checking if we are creating a new node and assigning data to that new node. Then we are checking if the root node is null or not. If it is null, then we are assigning the new node to the root node. If not, if there are a number of nodes in the heap already and we want to add new node, then the root node is assigned to current, and the size, we are adding 1 plus 1 to that. Let's say size is 7, we added 1. So that's 8 now. 8 will be converted into binary, which is 1, 0, 0, 0. After that, we are checking if the size is greater than 2. If the size is less than 2, it means we have only 2 nodes and we can just we don't need to find out the parent node. Here we are going to find out the parent node of the new node. Once we find out the parent node, we are going to check if the new node is going to be the right child of the parent node or the left child of the parent node. So in the given this binary number, if the last digit is 0, the new node is going to be the left node. Or if the last element is 1, then the new node will be the right node. After that, we are going to add 1 because we have just added the new node to the heap. And to maintain the property of the min heap, we are going to do function up heap bubbling. In the up heap bubbling, first we are getting the last node inserted in the heap and getting that into the current node, making sure that the current node is not null, and then it's not a root node. In up heap bubbling, we are starting from the bottom of the heap, where we are comparing the data of the last inserted data with the parent data. If the last inserted data is less than the parent data, in that case, the swap happens. And after that, we are moving to the next parent in the upward direction. Again, unless if it will continue until we reach the root node. And the main heap property will be maintained. Then the delete function. To delete the node, first we are the data is a variable is null. Last node that we get from this function and assign to last node. We are making sure that the last node is not null. If it is null, the heap is empty. If the left child of the root node is null, it means there is only one node in the heap, and then we will just delete that. If there are a number of elements, nodes in the heap, in that case, what we are doing, we are first getting the data of the root node in data. And then we are swapping the information. We are swapping the root node with the last node. After that, we are checking if the last node is the right child or left child. whichever once we figure it out, we are going to set that node as null. And also we are going to set it null from the parent for the parent also. Parent as null for that particular node. After that, we are going to reduce the number of nodes in the heap as we just removed one node. To maintain the property, we are doing down heap bubbling. So in down heap bubbling, we are going to check if the left child and the right child are not null, and then the left and the right child, either of them is less than the root node. If that's the case, if that is true, it is going to come inside the loop, and then program is going to check if the left child or left node is less than the root node or the parent node, and left node is less than the right node. If yes, then the program will come inside and it will swap the data between the parent node and the child, left child. Once it is swapping is done, program is moving to the next parent in the downward direction. Again, this condition will be checked and this will continue until either of this condition fails. So this will maintain the main heap property while doing deletion from the heap. Peak is just going to check if the root node is null. If it is null, heap is empty. If not, then it is going to give the data at the root. Using these functionality, we are implementing priority queues where we are creating main heap by passing true in the constructor for heap class. NQ operation we are using in heap operation insert data. To DQ, we are using operation delete from the heap. To peak, we are using the same peak operation. And to get the size of the priority queue, we are using operation get heap size.